And we are recording. Okay, cool. Just take that out. There we go. Okay, so thank you all for joining me again. Yesterday all we did was we put on a 4-inch wheel from CAD. It was specifically the AndyMark 4175 wheel, and we just fit that onto the end of the gearbox shaft, and then we shortened the shaft until it was almost flush. We gave it, I think, 5/1000 of an inch tolerance. Yeah. Um, so we added the wheel, we shortened the shaft, and then we grabbed one of the West Coast Products side bearing blocks from CAD, and we inserted that into one of um, the slots that we made on the bar previously. So this is now, I think, the fifth meeting or so, fourth or fifth. Hopefully by this point, you all are kind of getting into the vibe of how first robots are CAD'd. Just inserting and mating. That's the majority of it. So I'm gonna start moving slightly faster. My goal today is for us to get this drive rail completely finished with all the wheels and sensors and everything. I want to get to this point basically. I want to have everything except for the belly pan components, and the bumpers. Save that for next time, but I really want to have the drivetrain fully laid out within the next hour 30 minutes, and then we'll talk a little bit about what we want to do going forward, because obviously we'll finish this robot up over the next couple weeks, but then I want to talk about other plans, things that we could work on over the summer and possibly into the fall. But we'll save that for the end of the meeting. For right now, does anyone have any questions before we start?
For my shaft, I have an interference on the gearbox, basically. Could you take a look at that?
Yes, I remember you asked me about that yesterday and I didn't get to it, so let me check that quickly. Okay, turn off those icons by hitting K on my keyboard. Yep. So I'm going to check interference, include standard content. So you're going to get several interferences. The interference with the PEM nuts, those are expected. Interference with the bolts, those are trivial. So you're getting an interference with the top of one of your bolts here. And you're getting an interference with your shaft, and that's one of the issues we troubleshooted last time. That took a little while. But let's go ahead and figure out what's going on here with these bolts. So it looks like to me, I see the issue. So we used the 72 tooth pocketed gear. The pocketed gear is wider on the outside and then gets thinner on the inside. You're using just a standard flat gear. So what you need to do is you need to go into CAD, pull up a pocketed 72 tooth gear, which sadly do not come in steel varieties. You have to pull down. You want here it is, 72 tooth 20 DP aluminum half-inch hex bore pocketed gear, or West Coast Products -0123. That is the part number. And you'll want to switch that around. And then once that is in, that should fix most of your interferences. You're also getting some interferences with your shaft, and that's just, it's a trivial error. It comes because your parts are rotating independently of your shaft when realistically they would rotate together. So honestly, you could ignore it because that's not going to be a real issue. But what I would recommend doing is fixing some of your mates, like say the mates where all of these parts fit onto the shaft. You'll want to mate them so they always face the same part of the shaft. So what you could do is you could do like, this is obviously like a revolute mate, but you could do a revolute mate and then also do a parallel mate between one of the flat sides of your sprocket, the inside of your sprocket, with the flat side of your shaft, and that would keep those two parts like strongly together. So your shaft and your gears would always rotate as one. But again, it's a trivial error because it doesn't pop up in real life. It only pops up in CAD. And if you have other errors, we could fix them later. Other questions?
When the document says that there are newer versions of linked documents available, do we need to do anything about that?
It's typically best to just update all of your instances to the latest version. So you'll see a like refresh icon in your upper left, right by the insert icon. If you just hit that, you can update all of your documents. It almost never will interfere with anything. It just kind of gets rid of those annoying update icons that appear. It's mostly useful if you're working with multiple documents and you import one document into the other and you're doing source control. But in our case, this is like MKCAD changing their sources and whatnot, and creating new versions. So it doesn't really matter.
Effective length you said again?
Say that what? Say again? Sorry.
What was the effective length of the shaft you said?
The effective length of the shaft was change configuration 3.851 inches. I will paste that into general chat as well. Length 3.851 inches. And the way I calculated that is I just did simple math inside of the Onshape effective length, or inside of the Onshape dimension tool. This is a useful little trick that if you ever need to change dimensions of something, instead of doing the math yourself, you could just have Onshape do it for you. So I just kept taking off and adding numbers until everything was perfect. Okay, cool. So yeah, unless there's any other questions, we will go ahead and get started with adding the front wheels. I'm just gonna hide some of this stuff.
Were the bearing blocks annoying for any other people with like the interferences, or was it supposed to be like that?
No, it was me too.
Okay.
Wait, were you all having troubles with the bearing blocks, getting them together, or not?
No, the screws are just annoying.
Yeah, so it comes with special screws, which is slightly frustrating. It doesn't necessarily come with the ones that you can pull up in standard content. So yeah, I don't know why the ones I pulled up came pre-assembled in MKCAD. That just might be me having the advantage of having the app with more updated things that might be on the ones you're using.
If you search it up, you can find like the fully assembled bearing block. That's what I did.
I can also just go to your document and then pull up the linked document to that exact one.
Oh yeah, I forgot about that. If you just want to pull it off of my assembly, feel free. Okay, so we are going to go ahead and get started with making one of these wheels. And I'm going to start with this back wheel over here. No, let's do this one. Don't know quite what that is, but we'll figure it out as we go along. So, first thing that we need to do is we need to add a shaft. And I talked about this last time, but what we're going to do for this front one is we're going to add a Thunderhex shaft. So we need to go into MKCAD. You need to find out where the shafts are, shafts configurable, and then we're going to go to hex/Thunderhex. When I choose the 1/2 inch, we want to hit the check mark on Thunderhex, and let's insert a random length of, let's say, I don't know, 5 inches. So MKCAD, shafts configurable, add a 1/2 inch Thunderhex, 5 inch length piece of hex shaft. Actually, that might not be the best thing to do. How did we, trying to remember, how did we do the, oh, yeah, okay. I lied. Don't add in the vex/thunderhex. We want to just go to shafts configurable because that will allow us to add in the automatic retention methods, which is the exact same thing we did on for the gearbox. So if we use the standard shafts configurable, we want to choose a 1/2 inch hex profile. We're going to say the effective length will be 5 inches. We're going to do snap rings for both of them, include and merge everything. We're not going to bother adding the bearings, and we're just going to insert. That's going to give us a shaft basically identical to the one that we used on the gearbox, other than this is a thunder hex profile, while the gearbox shaft was a standard hex profile. Okay, and you should have something that looks like this. And so here I'll quickly demonstrate what the magic of thunderhex is. If I hide this, oh, that's not what I wanted to do. Let me hide you. No, it won't. But basically, the difference between a thunder hex shaft and a regular hex shaft is a thunder hex shaft is a hex shaft, but its corners are rounded. And the corners of the hex are rounded in such a way that it allows it to fit into a circular bearing called a thunder hex bearing. So we can insert this piece of thunder hex shaft into a round bearing, which means we can insert it in any orientation. And the advantage of that is you do not have to go through the painstaking process of trying to insert a hex-shaped profile through 2 hex bearings, which if you've ever tried replacing a piece of hex shaft on a robot and you've had to go through multiple hex bearings, it can be quite a pain to do, especially if your robot's like already been assembled and you have a bunch of stuff in your way. So hex shafts just kind of make things easier. They also become drilled out, so you could tap the ends to a quarter 20 or quarter 28 tap, and you could thread things into the end, which is a useful feature. That's how I typically do retainment, is that we'll just tap the ends and add a bolt and a washer. But snap rings are a little bit cleaner. So we have our hex shaft. Sorry, I need to rename these mate features quickly. Those are the thunder hex bearings that we added last time. Bearings.
Alex, which parts of the side bearing block did you mate to the left drive rail?
So what I did is I did a planar mate, and so I took the top face of the here, I'll actually make this transparent quickly. So I took the top face of this kind of inner square on one of the sides of the bearing block, and I did a parallel mate to the top face of the cutout that we made. And then with that parallel mate, you just have to make it so it can only go left and right by about 1/10 of an inch in each direction, and everything else should be 0.
Okay, thanks.
Okay, so we have the hex shaft. Let us go ahead and drop in our wheel. Just go ahead and get everything that we need. So we have our hex shaft. Let's go ahead and go back into MKCAD, and we're going to find a 4-inch Omni wheel. Hopefully something that comes completely pre-assembled. So MKCAD, verify, us. They use the 4-inch Vex Pro Omni wheels, which have a part number of 217-2584. So I'm looking for 2584 here in MKCAD. Great if I could find that. Omni wheel.
It's there if you search for it. It might be easier to just search.
Yeah. 217-2584. Parts. Might be in a, I don't know. Gonna search that. No, apparently the Onshape, whatever. This app still apparently has glitches. I could find it quickly, manually. Can't. Being blind.
It's called deprecated 4-inch Vex Pro.
Oh, it's one of the deprecated ones. Might not have that in my little app here. Okay, well I'm gonna go and just search for it using the old MKCAD, the one you all are using. Wheels 217-2584. Yep, okay, here we go. So deprecated just means there's a newer version out there. Slight improvements, so Vexpro can sell you more stuff. So we're gonna take that, drop that down. It does not come fully assembled, which is slightly annoying. What we're gonna need is we're gonna need two. The heck. Yeah, we typically need 2 hubs, but looks like Team 1678 only uses a single hub. So what we need to do is we need to go into MKCAD, go down to Versa, and we need to find their Versa hub, which is somewhere in here, if I can find it. That might not actually be what it's called. It's in Wheels. Use these last year. What are they called?
There's a separate folder for hubs.
Oh, really? I must have completely forgot about that. Here we are. You are right. MKCAD hubs. We want to add in the half-inch aluminum hex board Versa hub, which is part number 2592. Some of you all might remember these from Rosie. We had to use these on Rosie's wheels, and I really did not like them. But such is that. So these simply mate onto. I kind of demonstrate this here. What you'll do is the hubs just kind of interlock with the little turn. Go. Well, if I get the orientation right, hubs will interlock with these little rectangular-ish parts, and then you run screws all the way through, and then bolt it to the other side, so it takes a circular hub inside the wheel, and it turns that into a hex shaft, or hex profile, so you can run a hex shaft through it. So we need one Omni wheel, we need one half-inch hex hub, we need one piece of Thunder Hex with shaft retention. What else do we need? Well, we're going to need a sprocket. So what is this? This is an 18-tooth half-inch hex bore 25-chain sprocket. So we are looking for Vex number 3488. So go ahead and pull that up. Have to go down to sprockets and chain. I will choose the configurable hub sprocket. That just makes my life easier. Half-inch hex bore, 18 teeth. And that's that. I'll drag that over here. Spin it in.
Which one you selected?
Sorry, what was that?
The option that you just did for punch.
I'll drop them in chat, but it was 18 tooth, half-inch hex bore, number 25, hub sprocket. It was part number 217-3488. And then finally, we have what looks like a mag encoder. Yeah, mag encoder with magnet. They have a mag encoder with some sort of special adapter for it. So let's see if we can figure out that. I should have spent the time figuring out how that works, but I just haven't. So I'm gonna search through here. We want to find where the mag encoders are. I would have thought they would be in the electronics, but apparently not. Maybe they have a separate coder. Search up encoder.
Oh, on my thing, there's like a separate sensor section. I think it's in there.
Oh, sensors. This app sucks. It doesn't have sensors. Other documents, MKCAD. Going down to sensors. Here we are. To the mag encoder. Gray Hill. Yo, that's pretty neat. That might be useful. CTRE mag encoder. That's what I want. This looks interesting. This thing I've never seen before. Oh no, it's not an assembly. It just comes apart. That's awful. This looks like an all-in-one solution, so you don't have to do what 1678 did here and mount your own little machined bracket thing. We might not even bother with a mag encoder because they clearly left out some CAD details that I don't want to bother to figure out right now. But we'll.
Does that just count wheel rotations, or?
Yes, exactly. This will tell you how far your robot realistically moves. This is in comparison to putting your encoder on your gearbox, which a lot of teams do instead. But it's clear that 1678 did not design their encoder in there. And it's also kind of better to put your encoder further down the line because it gives you a more accurate measurement. I'm just going to delete the encoder for right now because I don't want to worry about that. We could go back in and add that later. Let's get the important stuff out of the way first. Okay, so we have four things. We have the hub, we have the wheel, we have the sprocket, and we have the axle. So the first thing I'm going to do is I'm going to mate the hub into the wheel. So the way I'm going to do that is I'm going to do a simple fasten mate from the face of this hub into the face of the wheel. And you might want to go into the offset here and change the rotation angle around Z. For some reason, auto defaults to rotate around X, though I've never used that. I've always rotated around Z. I'm just going to kind of change the rotation angle until it matches up with these little kind of squiggly rectangles on the wheel. I'm gonna kind of do 30, 35 degrees. I'm just gonna try and hone that in. 40 degrees. So for me, it's about 40 degrees to get those rectangles to fit inside the hub, which is realistically how it would work. So I'm going to name this half-inch hex Versa hub. And that's precisely how your hub fits on. Then I believe, I don't know if these things are actually threaded all the way through. Let me actually look that up. 7-2592 hub Versa hub. Because you might just be able, no, those are smooth. So those are through holes. They are, Does it tell us? Well, we could just look at the CAD model. These are 0.169 inches, which I think, I actually don't know what size holes those take. I look here in the CAD model, it takes a number 8 screw. If I've ever expressed to you all my hatred for imperial screw dimensions, now you all will understand. Because you cannot simply look at this and be like, oh, that's a number 8, unless you like memorize that. If we were using metric, it'd be so much easier. But I'm not going to rant about imperial versus metric right now. So I want to grab a few bolts and run bolts across this thing. So I will need some bolts that are at least 1¼ inch long. So I'm going to go into standard content. I'm going to grab some number 8. Let's do number 8-32 because that's pretty standard. What type of bolt do I want? Let us do a round head. No, not round head. We just machine. X head machine screw? No. Screw it. We'll just do socket head screw cap. Kind of the standard. Actually, yeah, socket head screw cap with the button head screw type. My personal favorite type of screw. So we want to do a number 8 32nd. Also, that doesn't matter. You can use whatever screw you want. We're going to choose the 1.25 inch length. I'm just going to drop 3. And in case you didn't know, if you just click on the parts where you want the mate to occur, so if I just click on 3 of these outer circles and I hit insert, it should automatically insert those screws all the way through. Oh, it did it, but it did it the wrong way, which is ever so slightly annoying. I need to go in here and flip all of these by hitting the flip primary axis, and I'm also just going to name them number 8 32nd 25 inch, just so I could keep track of what mates where.
How did you exactly align the Omni wheels like face with I forgot the part name, with the black part?
The hub?
Yeah.
So in the mate itself, you have to go to offset. You have to hit the little offset square, and then you change your rotation to rotate about Z. And then I just kind of incremented that angle until it finally fit with something. For me, it was 40 degrees. It might be the same for all of you. Okay, so we have our bolts through, and obviously whenever you have bolts, you need nuts. So we are going to go into ANSI inch, add some type of nuts do I want? Let's just do standard hex nuts. I'm not going to bother too much right now with it. 8 32nd, obviously, and we want to click on the little edges where we those nuts to go. Holy crap, those are huge. Why did it do that? For some reason it inserted 7/16, so I want to edit my standard configuration, fix that. Oh, that's interesting. For some reason I can't choose those type of nuts. Let's try that again. Round 2. X nut, X nut. Okay, apparently they don't allow hex nuts to go that small. Question mark? Maybe machine screw nuts. 8 32nd. Okay, here we go. click on those 3 square or circles where I want this to be inserted. These are a little overkill. Kind of annoys me how big they are, but they look good enough. Now, realistically, you don't actually get much grip on these. As you notice, the bolt actually doesn't come all the way out to the other side. So I might actually consider increasing the length of these bolts ever so slightly. Whatever the next size up is, 1.375, so 1/8 of an inch longer. That's just going to give them a little more grip so your wheel doesn't come flying apart. And then I'm going to rename those fasten mates, which are 8/32 hex nuts. Again, so I can keep track of everything. Okay, cool. Any questions about assembling this wheel?
What did you end up making the nut properties to be?
I just chose, it doesn't really matter, but let us see specifically what the configuration was. As long as the size is the same as the screw you used, so 8/32, and then I just chose machine screw nuts, and I chose the hex machine screw nut.
So I just came in. Sorry if I'm a little late, but I haven't really gotten to do the Onshape certification course yet. Do you want me to leave this meeting right now and just go do the certification course and get that done as soon as possible?
No, if you want to stay here and actually do this CAD with us, you can. Just know that, I can't slow down to cover certain topics that might be covered in the CAD certification course. If you feel comfortable with what we've done so far, and you just want to join in and do this, feel free to. But if you are very confused, it might be best to go work on that. But stay if you want.
All right.
So one quick thing I'm going to do is, for the sake of keeping instances and assemblies clean, one of the things I mentioned in my very first presentation was you should never really have more than 25 instances per assembly, and we are not even remotely, we're kind of close to finishing this. We're about halfway through, but we're already at 20 instances. And so like this wheel has 1, 2, 3, 4, 5, 6, 7, 8 parts to it, but it's just a simple wheel. So what I'm going to do, for the sake of keeping everything clean and also for the sake of just making our lives easier in a little bit, is I'm going to highlight everything that we just made for this wheel. And if you right click on all of that in your feature list and you hit move to new subassembly, what that will do is in your main document, it will create a brand new assembly called assembly 1. And I could drop that assembly into my drivetrain folder and rename it for everything there. So in this case, this would be a drivetrain level assembly. So I'm going to rename it drivetrain instead of brackets. It is currently one assembly lower than the left drive rail, which is A level assembly. So for this would be a B level assembly. And I'm going to call this 4-inch Omni wheel. Now if I go back to my original assembly, my left drive rail, instead of having 20 instances, now I only have 13. One of which is now an assembly that contains 8 instances inside of it and all of those features. So it just keeps everything nice and clean. Also, the other advantage is now that I know I'm going to need this thing again. this exact wheel. So now I could just duplicate the assembly for the back wheel as well. And when I do the right side drive rails, I could just duplicate this assembly again instead of having to go through and reinsert another wheel and a hub and 3 screws and 3 nuts and made all those. Just makes our lives easier. So always breaking down things is helpful. Cool. So now we have a finished wheel. And so next what I want to do is I want to go ahead and give me a second. I'm trying to figure out something. I really wonder if they just didn't add a hub on the other side. This annoys me because I've never seen a team do this, but it might be. You don't really need to support the shaft on the other side. You just have to worry about it possibly sliding, but it really shouldn't. I'm just going to copy what 1678 has in their CAD for right now. So what I want to do now is I want to have this hex shaft go into this the hex hub that we have here. The way I'm going to do that is I'm going to do a 2-step mate again. The first thing I'm going to do, I'm going to do a slider mate because this hex shaft should theoretically be able to move around inside of this hub. It should be able to go slide back and forth along the hub, and it should also be able to rotate with the wheel. So I'm going to do a slider mate there, and then in order to get the wheel and the shaft to kind of line up, because currently, as you can see, you have interferences between the two, I am going to do a second set of mates, which I'm going to do a parallel mate. And I'm going to do a parallel mate between one of the flat planes on the piece of Thunder Hex and one of the flat planes inside of the Hex Hub. So what that means now is if I, say, fix the wheel in place, the shaft now doesn't spin with respect to the hub. It can only slide back and forth, which is very useful for us. Because now whenever I do interference checks, you do not have any issues with that, as we saw with Ingeni's and lots of other people's issues previously. Giving me an error. Figure out why. A second. A, U. Why are you giving me an error? Shouldn't be. Yeah, I've rearranged the order of these. Oh, yeah. I should have been doing a cylindrical mate. That is my bad. I'm still learning on-shape mates. I don't use those quite frequently. Frequently enough, at least. Okay, so now that it's oriented correctly, the issue that I was having is a slider mate only has 1 degree of freedom, which is kind of that one axis that is able to move along. And so I was doing a slider mate, and then I was telling it that it needs to rotate in order to be parallel with another surface. And it did not like that because I was telling it to rotate in a degree of freedom that the slider mate already defined. So now that if you do the parallel mate first and then the slider mate, so you get them to line up and then you add in your slider mate, everything's fine. But if you do them out of order, you could get an error. If that makes sense. It does, it might not. I don't know if I'm making sense when I give these CAD lectures. Questions? Anyone? Cool, and we'll continue. So we have our hex shaft mated onto our wheel. So now we need to mate the hex shaft into our bearing block. And I'm going to do that using a single cylindrical mate. Well, first off, actually I need to rename those mates that I just made. I'm going to rename the parallel to be front axle slider, same thing. I am going to add now a cylindrical mate, the ends of one of the shaft to the center of the bearing. That should give me plenty of degrees of freedom. Yes, that gives me plenty of degrees of freedom, but it keeps it anchored where I want it to. I just realized I named these wrong. This should actually be front wheel. Two mates we just did should be front wheel, and this mate that we just did should be front axle. If I'm keeping with a consistent naming convention. I really should standardize how I name sketches and assemblies and or not assemblies, we've standardized assembly naming, but mates and whatnot. That might make everything a whole lot clearer. Doesn't matter too much right now. So we have everything approximately how we want it. As you know, or as you could see, if you kind of move everything around, you should be able to get a bunch of play in your system. That will become more clearly defined here in a minute. So what I'm going to do now is we'll see if this works. But I'm going to do a two-part mate again, putting the sprocket onto the shaft. So what I'm going to do is I'm going to do exactly what I did with the wheel. I'm going to start off with a parallel mate. I'm going to make one of these flat inside edges of the sprocket parallel to one of the flat edges of the or flat surfaces of the hex shaft. I'm going to just rename that 18-tooth sprocket. Pull that guy out here. So now that I have both of those parallel, I can then do a revolute mate. I want to do a revolute mate between and push this all the way up against the bearing. End of the sprocket should be touching the bearing. Sprocket. And now if I rotate all of these, they should all rotate together. Which, as we see, everything's kind of rotating as one, as it should be. Cool. So if we did our math right, and I think we did, this sprocket should be perfectly in line with this sprocket on our gearbox, and that's because of that spacer we made previously. 1678 did that math for us. But now if I look at it from a front view, I can actually notice that the sprockets aren't perfectly aligned. As you notice, there is a little bit of an offset between the two. Let me see if 1678 has that. I hide you. No, theirs actually seem to be perfect. So there's an error somewhere in our assembly, but it's nothing we can't fix. So let's quantify how much these are offset by. I look at the outer face of U and the, say, this face of U. So we are off by 0.62 inches, which is almost exactly a 1/16 of an inch. So that makes me wonder if I added in spacer somewhere that I shouldn't have. Check a few things quickly. Troubleshooting in CAD is something that you will become very familiar with over robotics build season. I'm just going to check a few things. I'm going to check to make sure the distance between the bearing and the sprocket at the very front is the exact same on ours, and it is within about 1/1000th of an inch. That is correct. What other sources of errors could we have? Maybe is their sprocket sitting further off the drive shaft? Theirs is 0.54 inches away. Ours is 0.46 inches away. Interesting. So maybe is our West Coast Products side rail thinner? Ours is 1/8 of an inch. Theirs is not 1/8 of an inch. Theirs is 3/16 of an inch. So that's why we have almost exactly a 1/16 of an inch worth of error, is because 1678 is using presumably older bearing blocks, which are 3/16 of an inch, while our newer bearing blocks are only 1/8 of an inch. So we need to add a 1/16 inch spacer in between our sprocket and our bearing. So that's super easy to do. If we just go to MKCAD and we pull up spacers, we're going to do a vex hex spacer. We want the spacer length to be 1/16 of an inch, which is 0.0625, sorry. Typically, I will go in and make my own spacers, but if there's something standardized, you could just insert. So I'm going to quickly delete the Revolute mate that I made previously, pull that sprocket out of there, and then do the exact same thing with this spacer. I'm going to do a 2-part mate. First one is parallel mate between 2 surfaces, 1/16 inch spacer. Now stuck inside my assembly. Pull that out of there. Then I'm going to do a Revolute mate between you and you, around 1/16 inch spacer. And then I'm going to re-add that Revolute mate I previously had on the sprocket to the 1/16 inch spacer. And now the sprockets line up basically perfectly. Make this transparent. You can see they have about 1/1000th of an inch worth of offset. That's, that's not going to be an error. I want to show all my instances so everything pops back up. Cool.
What spacer did you use again?
I used a 1/16 inch hex spacer.
Is that in a specific folder on MKCAD? Sorry, my on-chip is incredibly slow.
There should be one. Yes. Yes, MKCAD spacers. big fan of 3D printing your own spacers, but you know, you could also just insert them and make your life easy. Actually, that's one of the things that we should probably do if we were actually CADing in the robotics season. One of the very first things you do when you start your CAD is we should make a, in the robot part studio, make a bunch of standard spacers in here. So we'll make our 16th inch, 1/8 inch, 1/4 inch, 1/2 inch, 1 inch, and design those with 3D printer tolerances so that as soon as kickoff really happens, we could just start mass producing spacers that we know we're going to use on our robot. And then we just insert those from the robot part studio into here. Because why would you buy a hex spacer when you could literally 3D print it for 1/100th of the cost? But we're not going to worry about that for this CAD model. Cool. So hopefully all of you should be at this point where you have something like this. Kind of wiggly, kind of glitchy. I don't know why my hex shaft is glitching out every time I do this, but everything should be at least rotating together. So the final changes that I am going to make is I am going to I'm going to put some sort of spacer in between the wheel and the outside of the bearing block. So 1678 here uses a 3/16 inch spacer. So we shall do the same. So I'm going to go into MKCAD again, go to spacers, I'm going to go Vex Hex spacers, find, they don't have, how dare they? Okay, we're going to have to do our own custom nylon spacer. We can't do that either because those don't come in a hex profile. We're going to have to make our own spacer here. Fun. You'll have to do this hundreds of times over your FRC CAD careers. But very quickly, we're going to go into the drivetrain part studio and we're going to make a 3/16 inch long hex spacer. And the way you do that, you go to Inscribed Polygon and drag out a hex pattern. You're going to make sure it's 6. You're going to change the inner dimension to 0.505. I think we did this already. Yeah, we already made a hex spacer. You all understand how to do this. Inner diameter of 0.505 to account for 3D printer tolerances. Outer diameter should be about 3/4 of an inch, 0.75. Just name that hex spacer profile sketch, and we're going to extrude that thing by 3/16. I'm going to throw those all into a new folder. I'm going to rename that as drivetrain part 006 1/2 inch, no, 16th inch hex spacer. And then obviously whenever we create a new part, we have to edit its properties. So the most important thing is we assign its material to PLA. And we could change its appearance to something, you know, something that's not hideous, like the bright orange it gave us. Okay, cool. So once you have your hex spacer, you're just going to insert that, and you're going to do what we've done countless times now. You mate that into the hex shaft, and I'm going to do obviously 2-part mate, planar mate, I'm going to do a revolute mate, that and the outside pairing. And then finally, I'm going to finish up by doing a revolute mate from the wheel to hex spacer. It's going to be on the wheel. That gives me an error. Let me back up here a second. I did something that Onshape didn't like. I'm going to hit Control-Z a few times. Try and understand what. Oh, I see what I did. I did a planar mate. I should have done a parallel mate. Planar mates and parallel mates, not the same. One last time. Revolute mate between the spacer and the bearing. Okay. And a revolute mate between the wheel and... Actually, that doesn't need to be a revolute mate. That can actually just be a fasten mate. Okay. Doesn't like that. Okay, so it's sliding this way, and I don't want it to slide that way anymore. Best sort of mate to do, like me, doesn't like the fact that I did a parallel mate. If I just go back to using a revolute mate. Sometimes mating in Onshape is just trial and error. You get something that does what you want. Okay, there we go. Just a revolute mate. Okay. And very quickly, I'll demonstrate just, all we have to do now is shorten the shaft. So what I'm going to do is I'm going to do a revolute mate from the end of the shaft to this sprocket. So I have the C-clip flush up against the sprocket. Okay, see you later, Ingenie. Video will be posted on YouTube, hopefully later tonight. Okay, so it doesn't like the revolute mate, so I just need to pin it over here at the end. If I just do a fasten mate, nope, doesn't like that either. Sometimes troubleshooting mates in Onshape is a little bit of a pain. It's my issue here. I just do a parallel mate. Yeah. Just need to put those two ends together and not worry about any of the other constraints.
What made you connect the wheel or make the wheel not pull out of the shaft? Because my wheel is coming.
So I used a revolute mate to pin the, push the wheel all the way to the, what should we call this thing? Spacer, sorry.
Okay.
One of the concerns I have is how the heck does okay, yeah. We're gonna have to make a modification to 1678's design because I just really don't like that. If I go over here into the Omni wheel assembly we created, all I'm gonna do is I'm gonna duplicate the hub and add a hub to the other side. Because if I'm looking at 1678's robot, there's nothing that stops this wheel from sliding to the end of this axle. So it just makes me think that either they forgot to CAD that in, or maybe when they imported their assembly into Onshape, it might have somehow gotten deleted. But what I want is another hub here so that the wheel has something to retain itself against, basically. So inside that assembly we made for the Omni wheel, I'm just gonna duplicate wheel to mate it against. We're gonna have to delete some of those bolts that we made already. First, I'm just gonna mate U X Versa hub. We did the exact same thing we did last time, which is try and get everything to line up nicely, which hopefully it will. Do 20-degree offset that time, things line up nicely. I'm going to delete the actually, I'm not going to delete the hex nuts, but I'm going to redo their mate connectors, so they're now mating onto the Versa hub here. Oh, not what I want to do. This last one. Okay, so now we have a fully completed Omni wheel. This makes me a lot more comfortable, other than the fact that the screws again need to be slightly longer because they are not going through the bolt completely. I'm just going to change their standard configuration to just the next size up, which is 1.5 inches. Update all of those. There we go. Now this is a much more solid Omni wheel assembly. And if we go back to the other side, now we have something to retain the other end of the shaft against. So what we can do now is we can now shorten this shaft to whatever length we need. So we have an effective length of 5 inches. We have a spare of approximately, it's 1.7815. I copy that. I'm gonna just make sure the distance is to 1.7815. Okay. So what I could do is I could right click on that shaft, change the configuration, put the effective length in parentheses, tract that number, and then I'm going to add in a tolerance of 5 thousandths of an inch, because you always need machining tolerances whenever you're machining something. If I generate that, there we go. Now we can see our clip is almost on the end. You have a tiny bit of tolerance, so whoever's using the lathe doesn't mess it up. But that is how you add a wheel to a whatchamacallit, a drive shaft. As you can see, everything spins and it moves back and forth just like it should. That was a lot of stuff. I'm going to pause here for a minute, let you all catch up, and ask any questions or any issues you might be having.
So Alex, since I'm kind of just jumping in right here, do you want me to try to create like a new one, new file, and just try to follow along with you, or do you want me to just watch what's happening? Because I'm understanding most of what's happening. It's just like more or less the types of mates that I'm unfamiliar with because I'm coming over from like Inventor. So
What I would recommend you doing is actually just you're in the member of this team, right? Did you get an invite to that yesterday?
I don't think I did.
Okay. Send me your email that's associated with your Onshape, and then I will get you an invite to the team. then what you could do is create a folder with your name on it, go into my folder, and just copy the workspace. And so you could copy to the point that I'm at and then follow along.
All right. Do you want me to just send it in DMs?
Yeah, that works.
Okay.
Okay, so now you should be invited to the team. You might have to click an invite link in your email, but once you get into it, you'll see it on the left side of your screen. You should have a little icon called Teams. Join that, copy my workspace, and then jump in.
Do you want me to just create a folder with my name on it as well?
Yeah.
Okay.
So anyone else? Any questions? Anywhere you're stuck? Is there interferences that we don't have to worry about? They annoy me because it's better to not have interferences. Have them. It always annoys me whenever I import assemblies and they have interferences. No, I can't fix them myself. Ah. Standard content interference shouldn't be happening. Nope. Okay. Everything's good. So I am going to assume that you all are good and that we can move on. Last words or last objections before you move on to additional stuff.
I'm gonna just watch and catch up later because there's a lot of people on calls on my internet and my on-chip is not having it. So.
Cool. That means I can go faster. Final things that we're going to do. First off, we need a cam. Cams are very useful. So if we go into MKCAD and we go to Versa, we're going to pull up the West Coast Products cam, which is down here at the very end. Part number 3431. Cams are useful little features. They look kind of like Nautilus shells, and these will be the things that move our assembly, or not move our assembly, move our Omni wheel back and forth. Okay, so the West Coast product cam is going to go in that hole that we previously put on our wheel. So basically what we want to do is we want to do a, say a revolute mate between the two. And I'm going to just title that West Coast Products cam. That's going to allow it to spin, and as you all can see that if your block is over here kind of on the left, and your okay, that wasn't a revolute mate, that was a fast mate, my bad. As the cam spins around, it will eventually come in contact with your bearing block. So you could take a wrench or a hex tool, and you could twist this further over, and as you twist it, it will push the bearing block to the left. That allows you to tension your chain. It's a very useful little trick. Key thing with it is we need a bolt to go through it. So if I look up cam, it should hopefully tell me I've included countless numbers of these in my assemblies, and I still don't remember what the bolt that goes through it. It is a 10-30 seconds. So we need a bolt to go from one end to the other. That is at least 1.5 inches long. So I'm going to go standard content, 10-30 second, 1.5 inch. Insert it right here. And then I need a nut to go along with it. Again, second, third, through all, yeah, so it's not threaded. Just clarifying. Insert a nut onto the end. Great. And then I'm going to just increase the sizes of this guy ever so slightly. Editing the standard configuration instance. A little bit overkill, but it works. So hopefully, yeah, that shouldn't get in the way of anything. Okay, just rename those quickly. That is a 1.75 inch number 10-30 second bolt. That is a number 10-30 second inch nut. Okay, cool. That's basically that for this front wheel. One thing that I'm going to do now is I again realize that I'm starting to get a lot of instances, and actually no, I'm not going to bother doing it right now. I was going to turn this all into a single assembly, but we could do that later if need be. I'm just going to let it live now. So now what I want to do is I want to add in the chain. So if we go to MKCAD, this is pretty cool. If we go to sprockets and chain configurable, we add in some configurable chain. So the two sprockets we have is, I'm pretty sure they're both 18 tooth. Yep, 18 tooth chain, number 25 pitch, and the center to center distance for us is going to be the distance between the two shafts. So if I click on both of these shafts, it should tell me a center to center distance. Oh, it doesn't. Let me try clicking the center of this shaft to just click on the sprocket face. The distance between these two sprocket faces. Dang, it tells me a minimum distance. I don't want the minimum distance. Okay, how about the center of this bearing to the center of this bearing? Okay, well, not being helpful right now. Screw it, you know what? We're gonna do it the manual way. We're gonna guess and check until we know what a good center to center distance is. So sprockets chain configurable, 18, number 25. We'll do 14 inches because our rail, actually, no, let's do 12. Our rail is 28 inches long, so half of that would be 14, and we're obviously not all the way to the edge, so we'll do 12 inches. I'm going to do a realistic chain because that looks cool, and I'm going to insert that into the assembly. Insert. There we go. Didn't work the first time. Up. Wait. Inserted a unrealistic chain. I'm going to change the configuration. Realistic. Generate. Okay, there we go. So now we have a chain. And a chain that actually looks cool. So, you know, you don't have to do it. If you look at 1678's robot, they use the unrealistic chain model. But, you know, pretty nice having a realistic looking chain. Makes your CAD model look more legit, you know. So the way we are going to do this is we are going to, it gives us the mating points, which is pretty nice. And we're just simply going to do 2 revolute mates between the 2 sprockets, centers of the 2 sprockets. I'm going to do a revolute mate between this mating point that it already gives me and the face of this sprocket. And it doesn't quite fit in. Maybe if I try the other side. Here instead. Nope, still not quite. As you can see, it's a little bit offset to the left. So what I could do is I could manually offset it by, let's say, wrong direction. 1 inch is too much, 0.05 inches. Yeah, that looks good. So if I offset it by 0.05 inches, that will give me a good looking connection. Dan said, can't copy the workspace that I'm working on right now. Let me check something because it should allow you to duplicate it. Does it not allow you to copy it if I'm working on it, or can you just not copy it in general?
I just can't copy it in general, but I think it might be. I'm not entirely sure. I can't copy it right now.
Is it saying that?
I have no option to right now.
Oh.
Yeah.
Okay, let me try making it public. Now that it's public, you might be able to copy it.
Yeah, I got it.
Okay, cool. Hopefully that works. Just make sure you're not like. It might give you a I don't know. Onshape's weird, and sometimes it'll give you like a workspace that's like an identical copy, and we're like editing the same document. So make sure it's like your own document that you can edit without my interference.
I think it's good.
Okay, cool. So now that we have a chain in here, and we look at how it is, we can notice that it doesn't quite fit onto the sprocket, so we want to actually change the length of this chain. One of the really cool things about this, by the way, is when you generate the center-to-center distance, it will actually tell you how many links are needed in the chain. So here it is 114 links. That's just something useful for the build team. They automatically know from the CAD how long the chain length needs to be. Aiden says the center distance is 12.4125, so let's try that. 12.25. Generate. Obviously, at some point, the level of precision doesn't matter because adding or subtracting the chain will you know, overshoot or undershoot a certain number. But it said we needed 3 more chains, or 3 more links, sorry, so we are at 117 links, and it looks just about perfect. And if we pull it all the way over here to the right, see it fits in nice and well. So what I want to do now is I want to do a cylindrical mate, I think. That should give me the degrees of freedom I need. So if I do a cylindrical mate between you and you, just kind of the side of the sprocket, that should work. Yep, perfect. Everything fits together nicely. Obviously, I can't actually get the chain to rotate with me, which is sad. But it even tensioned the whatchamacallit. It pulled the bearing block to the point that it needed to be. So now the bearing block doesn't move to the left or right anymore. All it does is rotate. And now we have our first chain in. So I'm just going to quickly rename this to front chain. Chain. Hide those mates. Sprocket, we'll just let the sprocket, or the cam, sorry. We'll just let the cam spin. But that is our front wheel done. Minus the encoder. We're not going to bother with that for right now. Any questions before I move on? Because the second part of this is literally doing everything we just did for the back. So we have to repeat basically everything we did. The only difference is that we need to add a larger spacer for the back. Instead of this 16th inch spacer, we need to add like a half-inch spacer or whatever, the 16th inch plus the length of a sprocket. But do any of you have questions before we move on?
I have a question. Doesn't really relate to the CAD per se, but on
Sure.
on the 1678 robot, is there a reason that the hubs are facing like different directions for the front and the back wheel?
That I could think of. I think this is just a bad CAD model, honestly. Because they're using an aluminum hub back here. They're using a plastic hub up here. This plastic hub is not even mated correctly. And they're not even using a hub on the inside here. And they don't have a spacer, so this wheel is gonna scrape against this bearing block in order to rotate. Yeah, this is just a kind of bad CAD model. I don't know. This obviously isn't like 1678's internal CAD. This might have been like a rebuild from like a new student or something. Because some of these errors are just not realistic. These are definitely things 1678 wouldn't make on their real robot. If they did, they wouldn't compete at the level they do. But yeah, that's just bad CAD practice, I guess. Okay, so I guess we shall continue. Continue with the left drive rail. So what we are going to do now is we are going to basically copy everything we have over to this other side. And yeah, that should be relatively easy because we already made an assembly for the Omni wheel. So what I want to do is I want to copy the Omni wheel assembly, to paste that. Said copy. Oh, okay, it just took a minute. So copy the Omni wheel. I want to copy the bearing block. Actually, do I want to do? To do this? Yeah. The question is like, because the front wheel and the back wheel are so similar, I could just make an entire new sub-assembly of all of these parts and just reinsert it back here. But there are some changes that you have to make with the like shaft and spacer, so it's not really gonna be worth it. So I'm just gonna copy the wheel assembly. I'm gonna copy this bearing block. I need the 2 Thunderhex bearings over here. Just kind of grab all my materials that I will need. Just gonna need this hub sprocket. I'm gonna need the cam. I'm gonna need a chain again. Same length of chain, so I'll go ahead and paste that over there. I'm gonna need a spacer. That over there. I think this is everything we will need. So we're a little bit over the 25 instances I like per assembly, but you know, can't win them all. So now we're just gonna do exactly the same thing that we did yesterday and today, and just start assembling all these parts together. So I'm gonna kind of go through this pretty quickly, since we've already done this, but I'll explain it as I go through it again. I'm gonna start by inserting the Thunder Hex bearings into the bearing block. I'm going to just do a fasten mate there because technically the outside of the bearings do not rotate. Side does. Wait, is that how I did that? Yeah. If I were using hex bearings, I would actually have them revolve so you don't have interference issues. But Thunder Hex, because they're circular, they do not have those interference problems. I also need to copy this shaft, so I can copy this shaft over here. So next I'm going to do a planar mate to get the bearing block inside of the whatchamacallit, the drive rail. Just gonna mate the inside of the kind of the top face of that square inside the bearing block to the top face of the square that we cut out in the drive rail. And that's just going to be a planar mate. What do I name this? This is going to be rear bearing block. I want to change the limits so it only moves in the X and Y direction ever so slightly. I want to move it by plus or minus 0.1 inches. That gets that bearing block nice and settled in there. Cool. So next I want to add in my shaft. The rear shaft actually has to be slightly longer. So I'm going to change the configuration. I'm going to set it back to 5 inches because we can always trim it down later. So I'm going to do a cylindrical mate. I think that's what I did previously. If not, this is definitely what it should be. Cylindrical mate and rename that rear axle. Okay, now we have a cylindrical mate. Meeting's weird in non-shape. Okay, so we have the shaft in place. And then I'm gonna put my 3/16 inch hex spacer down here at the bottom. That's not how I want to do it. I want to do it a 2-part mate. First, doing a planar mate. We've always done with these hex parts, do a planar mate so you don't have any interference between your hex patterns and your hex shaft. Name that 3/16 inch hex spacer. That's what it is. Out. And I'm going to do a revolute mate. Between that and the bearing. Which technically isn't correct because you're not pinning it to the bearing, but how it goes sometimes. Actually, it should be a planar mate, not a revolute. My bad. Sorry, Onshape. You don't need to get that mad at me. No, not a planar mate. What am I doing? It's a parallel mate. Is it? How did I do this previously? I had it as a revolute mate, so why is it getting mad at me now? Shape is upset about something I'm doing, and I'm not quite sure what it is. This entire project has just been great practice for my on-shape mates that I rarely ever use. That's what I'm really getting out of this. Maybe a cylindrical mate? be less annoyed. Nope, still doesn't like it. Weird. Sorry, I'm just trying to figure this what the most efficient method for this is while you all catch up. Rear axle, I did a 2-part mate slider and a something. Oh, I only have a cylindrical. I do a Revolut mate between you. Then I do a parallel mate. To you. That was a slider mate, not a Revolut mate. Okay, there it works. Sometimes the order of your mates cause issues that I don't fully comprehend, but you know, with practice comes perfection. So now that we have our spacer on there, I'm just gonna go ahead and throw on our wheel, and that's gonna be a simple Revolut mate as well. Now, to start with the parallel mate. Then do the Revolut mate. Okay, cool. These 2-part mates are kind of annoying, but it gives you a better result in the end. If you look at like StealthBot, everything was just a fasten mate, basically. Which technically isn't correct, so now that we are doing our mates correctly, everything comes out nicer. Okay, so now I'm not going to worry about retaining the shaft just yet. Now I need to put the sprocket on, and I need a new spacer. So I need a spacer that is a 1/16 of an inch plus the length of the sprocket, the width of the sprocket, because we are going to be running a chain on this rear sprocket. So we are 1 sprocket over from the beginning. So we need a 1/16 of an inch plus, what was this? 0.361 inches. I'm going to go back into the Onshape Part Studio, do the same thing that we've done several times now, which is make a hex spacer 505. Outer diameter is going to be 0.75. I'm going to do some math. So I'm going to do 16th plus that brackets, and it comes out to 4.2 or 0.424. Sorry. Obviously, I need to rename this. I'm going to throw those both in a folder. Sorry, that is not part 6, that is part 7. Rename this to the proper component, drivetrain part 007, 0.424 inch hex spacer. Then I want to change its material, So it's a PLA, so anyone who pulls this up will know that this is a 3D printed part. They can print it. So if you don't assign the material, someone might think, oh, this is an aluminum spacer, and I have to make it on the lathe. No, super simple. Just 3D print it. Obviously, we need to go in here, insert that, and we're just gonna insert that like how we insert all of our other hex spacers. Planar mate onto one of the flat surfaces here. It's stuck in the middle, so I need to hide that. Out over here. Revolute mate between this and the bearing. Bring all parts back. Rename my instances. And do my sprocket. Sprocket. Let's give you the rear. Specify that this is the rear sprocket. Just in case I need to go back in here and troubleshoot mates at a later point, I'll know which sprocket is which mate. Coolio. So final thing to do is to define the shaft. So I'm going to do a revolute mate from the end of the shaft, effective end, to the sprocket. It's going to be rear axle. Yeah, rear axle. That did not like that, apparently. What did I use for the last one? I used a planar mate because that has more freedoms associated to it. Yep. And then we just need to shorten this axle again. So I'm going to get the distance of the effective length, which in our case is 1.4205. So I'm going to change the configuration. So I'm going to do in parentheses 5 minus that number. Then I'm going to add 5/1000ths of an inch, and I'm just going to change that. Remove the 5/1000th of an inch we would otherwise subtract. So it's 5 minus 1.420 in parentheses. So it's going to be a 3.58 inch shaft. Generate. I'm going to hit OK. That shaft fits on there perfectly. And that's basically it. Now we just have a cam. Quickly add that in. Let's go to product cam. Need the screw that it came with, so I just copy those over here. Screw. We also need the nut that it came with that we inserted previously. Insert the screw. If we remember, that is a 10/32 1.75 inch bolt. Bolt, screw, whatever. I don't know what the difference is. I think if it's used on a robot, it's a bolt. If it's used in a wood project, it's a screw. And then we add the 10/32 inch nut. Then finally, we add the chain. The chain is not showing its mates, so I want to show. I do this. Should be a thing that allows me to show its mating point. I could also just hit K. That's kind of ugh. Okay, we're gonna do this the way we previously did it, which was just go into MKCAD and get a shaft, or not shaft, chain. Chain configurable. Aiden said it was 12.4125. Realistic model. For some reason it doesn't like inserting that. Why? Okay, insert a simplified one and then change it to realistic. Cool. Right click, change configuration, realistic. There we go. Generate. So that makes me happy. I'm going to do a revolute mate, that mate connector, and inside of this sprocket face here, I obviously need to offset it by about, what was it, 0.05 inches. You do it in the other direction for 5 inches. Yeah, that looks good. To rear chain. Now you should be a cylindrical mate because I need it to both rotate and back and forth so it fits perfectly. No little minor errors that could get in the way. Also rename you to rear chain. We have an error. Interesting. What's happening here? Our sprocket on this rear chain is not at all lined up with our sprocket over here. So what could be the issue? I see the issue. I mounted the sprocket the wrong way. This sprocket should be flipped backwards. So luckily, since I named all of my mates, it should be easy to go in and fix that. I'm looking for sprocket, 18-tooth sprocket. Here we are. Revolute mate. I want to change the mate connector on the hub sprocket from that front face, this one, to this rear face. I want to hit solve. I'll flip it around. Solve again. Up. Came up with a bunch of errors. Easiest way to fix this is to just delete. I'm also going to delete this chain one so it doesn't get too mad at me. Move the chain out of the way. Just could delete both of these hub sprockets. Mate is the other one. Okay, round 2. What the heck? Why is it still following me? I am confused. Show mates. Oh, the rear axle is pinned to that. Suppress you for a moment. Suppress tool, pretty neat feature. Allows you to fix things temporarily and then go back in and fix them again later. So again, I'm going to remate the sprocket. There's probably a much more efficient way of doing this. I'm just going to do one flat edge, another flat edge, rear 18-tooth sprocket, out, revolute mate, the back end of U to front of U. Again, here, 18-tooth sprocket. I'm going to unsuppress this, and it should give me an error. Yes. Just want to make sure it is now going to the front here. Hide. Now my sprockets should line up perfectly, which they do. Finally, I can add the final cylindrical mate between this mate connector and this guy. And this again be named rear chain. Let's drag those two chains together, so if I ever need to find them, they're both in the same place. Okay, so that was fast. Kinda talked a lot. Kinda didn't pause to ask questions. But now, as you all see, we have a completed drive rail. So this entire left side assembly, effectively half of our drivetrain, is now complete. I will pause for any questions.
So this is like unrelated to the CAD, but why are all or almost all of the bolt heads on the rail facing the inside of the bot? Is there a reason for that?
Not particularly. I mean, it kind of depends. You want to make some of these things easy to access. So it might actually be worth it for me to put this bolt head on the outside of this cam, for instance, because if I need to take the cam off, I don't necessarily want to take the entire wheel off. But currently, the only way I can access this screw is by taking this wheel off. So you kind of just have to think about it in terms of ease of build, ease of manufacturing. You also have to think about it in terms of are you going to get interferences somewhere? So one of my fears and one of the things we might have to fix here with this wheel is actually flipping the wheel around so the bolt heads are on the outside. Here you have like almost a 1/4 of an inch worth of stick out. While with a bolt head you might only have you're getting half of that, less than half. So this might actually end up interfering with our bumpers. So we will need a wider bumper assembly. And if our bumpers go over spec, then we're going to run into issues. That was something that Rosie had problems with, is we would put bolt heads on the outside of the frame and they would interfere with our bumpers. I had to yell at students about that. So part of the reason we always CAD in our bolts is to make sure that we never run into those interference issues. Like here. If you didn't CAD in this bolt, you never would have known that that would have interfered with the drive rail and you needed extra CNC holes in order to access that. Or in Angini's case with the non-pocketed gear. Might not have noticed that your bolt would interfere with it otherwise. Other questions? Okay. Well, I know I went pretty fast, so this video will be up later tonight, so you all can go back and look at it and hopefully catch up sometime this week. I didn't quite get to everything I wanted to do today. I really wanted to get both drive rails finished. The great thing is, next time, all that we need to do is we're going to duplicate this assembly. Actually, we could go ahead and do that now, I think. But basically, we're going to duplicate the assembly and then switch around the chains. So your inner chain should always go to your front wheel, and your outer chain should always go to your back wheel. Actually, I don't think that matters at all. Maybe we'll just rename this to drive rail and have both drive rails be identical. Sometimes you do need to worry about your opposites like being inverted. But in this case, I don't really see the difference between left drive rail and right drive rail.
Is there a way to just mirror everything?
No. I wish there was, but there's not. What we can just do is we can now duplicate this drive rail. So now I have copy. So what I could do, I could just rename this right drive rail. And now I could just go in, find my chain mates, and delete them. Like here, rear chain. Actually, I can't really do that. I would actually need to. I need to swap around the spacers as well, because technically we're swapping the front and the back wheels whenever you invert anything. But we will worry about that next time. Basically, like that. Up around 180. So then we could create a new assembly and actually put both of those together. One thing we'll actually go ahead and do quickly, just so we could get that prepared for next time. Let's create our final drivetrain assembly, or like our overarching drivetrain assembly. So we want to create a new assembly quickly. I'm going to rename that drivetrain train. And this is going to be our highest level assembly. So this we now know is going to be an A level assembly. We could just call this main drivetrain assembly. And inside this assembly, our left and right drive rails can go. So we now need to demote these left and right drive rails to B level assemblies. Because now there is an assembly that is higher level than both of these. And now our gearbox assembly, because now that's a part of a B level assembly, that's actually going to be demoted to a C level assembly. Same thing with these Omni wheels. That's going to be demoted to a C level assembly. So realistically, I should have done this planning more at the beginning, so I wouldn't actually have to go in and rename all those, but it's not a big issue. So now I know I'm in an A level assembly, so I should only really be inserting B level assemblies here. There we have it. Now have two drivetrain rails. And you know what? Let's go ahead and finish up the drivetrain today. Let's just, all we need is now 2 bars. We can worry about adding gussets and other things next time. Let's just go ahead and finish that up. So all we need is a front bar that is 25.5 inches long, and the rear bar looks identical. They both have the same hole profile to them. My Onshape froze? Oh, okay, it's back. So I think their front and rear bars are identical. Oh my god, what did I do? Oh, I opened bumpers. So let's just go ahead and make a front and rear drive rail. The spirit of good practice, I'll make the front and rear different because typically they'll have different mounting holes, but they might, for all intents and purposes, be the same in 1670's robot. So I'm going to create a 2x1 rectangle. I'm going to use the offset tool. I'm going to offset inwards by 1/8 of an inch because we use 1/8 of an inch metal for drivetrain applications typically. So I want to extrude that by 25.5 inches. I'm going to rename that to drivetrain part 008 front drive rail. Now one thing that I'm going to use is, I showed this off last week I think, is the feature script for tube converter. This is available on Chief Delphi under Julia's feature scripts. If you add that to your workspace. I think I also linked it in Discord from last week. But if you click on that feature script and you click on your part and you go to 1678 style, you can add in all these holes just like how 1678 has it. So if I look at how they do it, they have basically 3/16 inch holes that are separated by half an inch. So I want 0.196. Yes, theirs are slightly smaller. I don't care. I always do 0.196. Turn down to hole spacing half an inch. No offset. Hit OK. So that is our front drive rail. Obviously, whenever we make a new part, we have to assign the material. We want to do 6061 aluminum, which is what these are made out of typically, to edit its appearance just so it looks more reasonable. Throw those both into a folder. And then I'm going to we're going to make something an identical bar for the time being. This might have to change later, but for right now, they're going to be identical. Again, 2x1 bar, offset inside. So I have now an eighth of an inch, not a seventh of an inch, eighth of an inch. The rear drive rail profile, extrude 25.5 inches. Again, use the tube converter, 1678 style. Everything stays the same. Rename drivetrain part 009. Rear drive rail. Throw those into a folder. Add our material. And make it look cool. So now, very quickly, I'm going to go into our part studio and I'm going to insert the front drive rail up here at the front. The rear drive rail here at the end. And I'm going to very quickly mate these together. And I could just do simple fasten mates for this, I think. Just kind of mate them by the corners. I can rename this left drive rail. Mate this again. Right drive rail to the front. I'm going to mate the rear drive rail. Up, there. There we go. And there you have it. Now you all, once you all have this assembly, you have created your effectively very first West Coast drive in your own CAD file. So congratulations. There's some minor tweaks that we need to still add. We have to add a bunch of holes to the left and right drive rails still. Add gussets, add a belly pan. But for the most part, you know, this is something that you could go out and physically build, and mechanically it is sound. It is, you know, identical to what 1678 built in 2019. So, you know, this thing is pretty cool. I don't think we'll bother adding like the bumpers. Those are just, yeah. No one likes CADing bumpers. Bumper attachments, whatever. Not gonna bother with that. Next time we will finish up the drivetrain. We'll probably go in and make a belly pan. Potentially add in some electronics. We'll definitely do the gussets. But what I want to start getting onto is the bigger stuff on this robot, which is the elevator and the mechanisms that mount onto the elevator, like this intake, this other intake, all this stuff on 1670s robot that I don't yet understand. So yeah, there's a lot of cool stuff coming up. We'll also kind of start moving a little bit faster on the elevator stuff as well, now that you all have a good understanding of kind of how this CAD process works. Any questions before we wrap up for today?
I don't know if you care or not, but your mate is called Rain instead of Rail.
Ooh. I do care, thank you. Rail, there we go. Other questions?
Why did you create two of the two front rails if they're identical?
Because you might have to customize one or the other in the future. So like, for example, on Rosie, the battery was mounted to the rear rail, so we needed to have two separate holes in the model that weren't on the front rail. So yeah, just good practice.
Or we could just do the easy fix and just drill it into the battery. Come on.
Oh yeah, obviously. Of course. So I think I'm gonna leave it there for today. Final thing I want to talk about is this is something me and Aiden were discussing yesterday, but you know, I want to pull the rest of you into it, and by the rest of you I mean the two other people in this meeting. Hopefully we'll get more people over the summer to join this. But starting to think about what cool stuff we could do over the summer, because you all are kind of the students who are most passionate about robotics and interested in doing cool projects. So we've been starting to think about like what cool things could we possibly build over the summer. We could obviously continue CADing. Like once we're done with this, we could go and build another robot. But you know, at some point in time, you get kind of tired of CADing first robots. So I've been thinking of like, you know, there's a drone project that I have sitting here in my dorm that I've been meaning to finish for a while. I'm trying to 3D print my own drones. There's a rocketry project that I've been wanting to do for a long while. Basically building your own rockets that could like have active control. So you have like fins and thrust vectoring and that sort of stuff on like a model scale. There's a lot of cool things that we could do over the summer that involve not only CAD design but actual, you know, fabrication and programming and wiring and electronic stuff. So if there's anything interesting like that that you all want to do, or if you're interested in just doing something like that, please let me know, and I will make sure to actually get something set up and tie you all into that. Other than that, I think we're good. Tanuj, did you have something to say? I see you unmuted your mic there.
No, I was just gonna say like I'd be interested depending on whatever we do.
Okay, cool. If you all have any ideas as well, you know, feel free to shoot them to me. Like if you've had a project that you've been wanting to work on for a while, I would love to hear it. I'm hoping that maybe the team will fund one of these projects because, you know, it'd be great if I could do some cool engineering and didn't have to pay for it out of my own pocket like I constantly have to do here at Mason. But you know, hopefully I think within the next week or two we could come up with a cool idea, and we can pitch it to the captains and see if they're willing to fund it. Anyways, I'm gonna wrap it up there. Feel free to shoot me a message on Slack if you have any questions. Other than that, I will see you all either next Tuesday or next Wednesday. Thank you all for joining. The heck do I end this video? See y'all.